Welcome to part 2 of the video on iteration by substitution. In the second part, we're going to solve more examples of iteration by substitution. Here we have the integral of the natural log of x over x dx. We know that the derivative of the function natural log of x is 1 over x. So we're going to make the substitution u equals natural log of x. And if we do that, we have that du dx, thus the derivative of u with respect to x, equals 1 over x. So here we can replace in our integral the natural log for u, and here we have natural log times 1 over x. So here we can replace that by u times du dx. And then we have the dx also there. Now we know that we can cancel the differentials dx and get that this becomes the integral of u du. And this is one of the easiest integrals. This equals u squared over 2 plus c. And now we only need to replace back u. We substitute back u by the natural log, and we get the answer to this integral. That will be natural log of x squared over 2 plus c. That's the answer. That was easy enough. Let's see a little more complex example. Here we have the integral of e to the x over 1 plus e to the 2x dx. We can also write this integral as e to the x over 1 plus e to the x squared. That's just by properties of exponents times dx. I forgot to write dx here. So here we're going to make the substitution u equals e to the x. That means that the u dx will also be e to the x, because the derivative of e to the x is e to the x. So we're going to replace now in our integral, and in the numerator we're going to replace e to the x by du dx, and in the denominator we're going to replace e to the x by u. You may ask, how do I know that this will work? Well, I just know. You also know when you have experience solving this type of integrals. So we're going here we replace the numerator, the denominator in the denominator e to the x by u. So we get 1 over 1 plus u squared times, here we have e to the x. I'm going to replace it by du dx. Then of course times dx. Here u squared is e to the 2x, and du dx is e to the x. Here we can cancel the dx and we get this integral. And if you look at your table of integrals, or the little table that we've seen in day 15, you'll see that this integral equals the arctangent of u. You can check this by simply taking the derivative of this. We know that the derivative of the arctangent of u is this function. So we know that this is a primitive of this function. So we have this integral in terms of the variable u, so we need to substitute back. We know that u equals e to the x, so we substitute and we get arctangent of e to the x plus c. That's the answer. So that's all for now. Thank you for watching and see you next time.